Alright guys, this is Unit 5, Lesson 5, and it says modeling with systems of equations, and basically what that is we're going to be setting up some word problems here, because there's a lot of real-world scenarios that we could use for systems. Basically, when we have two different quantities, two different variables, that are related in two ways that would give us the system, we could set it up. So let's look at our first one here. It says Jonathan has 9 bills. So that's just the number of bills, not their value, obviously. And all the bills are either $5 bills or $10 bills. So we could have a variation of the different amounts, but they have to add up to 9 total bills. So on part A here, you're going to fill out the table. This would represent the number of 5s he has. This would represent the number of 10s. And this would be the total amount of money for the bills. So go ahead and fill out that table. You should be able to do that now. So hit pause and do it. Okay, let's see how you did. Obviously, if he has 0 5s, he needs to have 9 10s to give a total of 9 bills. And that would be $90, obviously. 1 5 means 8 10s, so that would be a total of 85. 2 5s would make 7 for a total, again, 9. And that would give us $80. And finally, 3 of these means he must have 6 of those. That way we're keeping the 9 bills total. And then 85. So you can see that as the different amount of bills we have varies, but there's still the total amount is the same. So we can't really figure this out unless we had more information than just the fact that he has 5 or 9 bills. We don't know exactly how much each, so we need more information. Now, part B, if F represents a number of 5s and T represents a number of 10s, then what would this expression here represent? So again, I want you to write out what would the 5F plus 10T actually calculate. Okay, so hit pause and give that a try. Alright, did you say something as this is the total amount of money Jonathan has in wallet? Total amount of money in Jonathan's wallet. And hopefully you understand that this 5F means that F represents a number of $5 bills. And that would be the number times the amount. So the amount is $5, that's its value, plus the number you have. That would be the value of 5s. This would represent the value of 10s. So together, that would give us a total. Let me just get some arrows going here. So that right there. And this right here would represent that. So obviously, together, that would help us find the total. And that's going to help us solve this problem here. Alright, let's look at part C. It says, if Jonathan has a total of $55, now you should be able to set up a systems equation involving F and T, so you got to use those, that can determine how many of each bill he has. Solve the system. Okay. Remember, there's a total of 9 bills. So, I want to see if you can do this on your own. So hit pause. There are 2 equations we can now set up, and try that, see if you can solve it, and only hit play once you've given it a try. So do that now, please. Okay, let's see how you did. So here is the system I set up. So remember, F is the number of 5s, and T is the number of 10s. And if we added up just the number, not the amounts, we knew there was 9. So see, that is an equation we could set up. The other one is the one they gave us. If we do the amounts, if we do $5 times the number of 5s, plus $10 times the number of 10s, that would be the total amount we have. So this 55 deals with amounts, so that's why we have to put amounts with it. So there's a system that we could have set up. And now you can just see how I solved it. You guys should know that this is all set up to solve like an elimination, because everything's lined up for us. So I'm just going to reveal everything I did. I'm not sure the order here. It is down here. So you can see I multiplied that by -5 to make opposites right there. And when I did that, I came down here, solved for T, and again, there we go. Now that I know T is 2, I'm going to plug it right here. I could use this one, but that's a lot more math, so I just did it up here, and now I know that F is 7, so then we want to write out what we have, and you can easily check your answer, guys. You really should get in the habit of checking these. It'd be really simple. Since we have 7 5s and 2 10s, we can just see the amount, and we can see that adds up to 55, so we know our amount is good. So if you need to, hit pause, fill this all in, and hopefully that went okay for you. Let's try the next one. All right, so part D says, let's say we are told that Jonathan has 7 bills this time that are 5s and 20s. And we were told that that adds up to $120. What you need to do is set up and solve a system, and then tell us if we were told that this was true information. Is it possible for him to have 7 bills that are 5s and 20s that add up to $120? So again, I want you to do this whole problem on your own, and let's see how you do. So hit pause and try that now, please. All right, first of all, how many of you guys set up some type of let statement for your variables? Since they didn't tell us what the number of 5s and the number of 20s variable, we have to make our own. So if you put variables in equations, you need to tell people what they each represent. How do we know which one's the 5s and 20s if you didn't tell us? So this is important. If they don't give you variables to use, set up your own let statement. Now let's see what type of equation you got. So the number of 5s and the number of 20s, there were 7 of them. We just counted them. Then we know their value is supposed to be 120, so now we have to put the values with those. So obviously 20s have a value of 20, and $5 bills have a value of 5. So that's the system that we're looking for you to set up. Now, again, set up for elimination, and you can see I decided to go with -5 to make these opposites right there. Remember to distribute to all 3 parts. Now we bring up this new equation down here. You can see we have the perfect opposites that we're looking for. These would make 0. And then I just combine like terms here, combine those, and I got 85. Then I went ahead and divided. And when I did that, I found that I got y equals 5.6 repeating. So this really doesn't make sense because we can't have 5.6 number of bills. We could have 5 bills or 6 bills. You can't rip a bill into 2/3. That wouldn't work. So this is not really a viable answer. So therefore, we want to say something like this. We were not told true information because we can't have fractional amount of 20s. If you think about the problem, we were supposed to have 7 bills. Well, if we had 7 20s, that'd be 140. So let's try 6 bills. 6 times 20 is 120. 1 more bill would be 5, and we could never make 7 of these things add up to 120. So we used math to prove that this information was incorrect. That's why math is super cool. All right, let's try the next page. All right, for this problem, we have 4 parts. I'm going to have you do each part separately, but let me give you the answers as we go, so that will help you do the next one. So we have Samantha. She's at a concession stand. She bought 3 pretzels, 4 sodas, and paid a total of $11.25. Raza went to the same stand, bought 5 pretzels, 2 sodas for $8.25. This is a classic systems problem. You're going to see this one come up quite a bit. So part A wants you to know, could the pretzels cost $1.75 each, and could the sodas cost $1.50 each? So we want you to say yes or no if these could be the actual prices. So see if you can figure that out. So try that now, please. All right, what did you do to figure this out? Did you do something like, well, I know there was 3 pretzels she bought this, and then she bought 4 sodas. And then if you added that all up, her cost was supposed to be $11.25, and that worked out. So that was good. Now remember, a system and a solution has to work for all the information. So would these prices also work for Raza? So you couldn't just do this. You have to check both. So Raza had 5 pretzels and 2 sodas, and remember his total was supposed to be $8.25, but when we total this up, ooh, that is not right, sorry guys. There we go, that's what it was supposed to be. Came to $11.75, and that is not the total we paid, so these prices aren't the correct prices. So there we go. And we should technically say something like, no, these prices do not work for both scenarios, so that's not good. Okay, let's move on to part B here, and again, hit pause and fill things in when you need to. So part B, same information, is let X equal the unit cost. So how much the cost of pretzels are, let Y be the cost of soda. So they gave us our variables. Now you need to come up with a system that models this information. You don't have to solve it. Can you come up with a system on your own? So please do that now. All right, what did you get? Let's see if I can find my answer. It's in here somewhere, maybe not. All right, I found it. So hopefully you see that we have 3 of the pretzels, 4 of the sodas for a total, and 5 of the pretzels and 2 sodas. There's your total. So a perfect system to model this situation that's going on. All right, now part C, you're just solving this. So again, you should be good with that. So go ahead and solve that now. Only hit play once you have an answer. All right, let's see what we did. There we go. So we solved the system. I use -2 here, so therefore this would become -4, and those would cancel out. You can see my work over here. Y is canceled out. Solved. I got X is 0.75. Now, does that make sense? So we're saying the pretzels are 75 cents. Those are pretty cheap, but I guess it's possible to have, maybe they're small little pretzels. Now that we have the 75 cents for the pretzel price, I could plug that into one of the equations, right? So I could plug it in for here or here. I just chose the top one. So there's the 75 cents. And then just solve the equation like we know how to. And when we did, I got this to be $2.25. So now we know the cost of the sodas and the pretzels. And again, you could check your answers, which I didn't do, shame on me, by plugging it back into this other equation we didn't do. So if we did 5 times the 0.75 plus 2 times the 225, is that going to come up with the total? And I'm sure it will if you plug that in. All right, so we're down to one last part on this one. This part I think you guys could do easily. It says if Lee, I think that's how you say, went to the same concession stand and bought 2 sodas, how many pretzels would she need to buy to spend the same amount on both? So again, try this on your own. Only hit play once you have an answer. And how did you do? Did you get 6 pretzels? Pretty easy, hopefully. 2 sodas. There's the cost of the soda was $4.50. We want to know how many pretzels would go into that, so I just divided by the price of the pretzels and got 6. Pretty easy question. All right, and our last problem. This one would be a geometry problem, and you're going to see rectangles and geometry be used actually kind of quite a bit when we start doing some more algebra systems. So we have a rectangle, perimeter of 204 feet. Its length is 6 feet longer than twice its width. If the length stands, or if L stands for the length and W stands for the width, write a systems of equations, meaning 2 equations that models the information, and then solve it. So could you write a systems for this problem, meaning 2 equations? Once you have that, go ahead and solve it and see how you do. So again, try the whole problem and only hit play once you come up with an answer. All right, here we go. You should have gotten, hopefully, if you did it right, the length was 70 feet and the width was 32. So if you got that, nice job. I like to draw pictures. Here's a rectangle. Obviously, a rectangle has 2 lengths and 2 widths. You should know perimeter means all the way around. So if I add the 2 lengths and the 2 widths, that equals a perimeter. So this information helps us with one equation right there. So the perimeter is equal to 2 L's plus 2 W's. The other equation is embedded right here. Look, that's an equation. Length is means equal. So L equals 6 more than, 6 plus, twice width, which is W. So there's the other equation right there. Length is 6 more than, twice the length of the width. Now that we have this set up, hopefully you see that this is a one to use substitution. We could move things around if you want and did elimination. Look, there's your single L. We could take this amount and substitute it right in for the L, which I did right here. And remember, that means 2 times L, so now I had to distribute through. Now I just solved it all the way. You can see all my work here. And just go ahead and read through that. I don't need to explain it. You're smart people. And when I did that, I got W was 32. And then I found my length. Once I know my width, I could plug it in, find the length. And then I checked it just to be sure right over there. Okay. So I know there's a lot of information on this page. So I'll kind of scroll through. You could pause it, rewind it, fill it in when you need to. But hopefully that went okay for you. And we'll practice a lot of these on the fluency in class.